Welcome to the Director's Chair. Think of your upcoming Cambridge Computer Science exam not as a simple test, but as a blockbuster movie production. Scene by scene, you need to build your blockbuster answer. You've got to cut the filler and keep the action focused. Okay, let's dive into this explainer and decode exactly what Cambridge examiners are looking for. Whether you are tackling syllabus code 0417, 0478, 0983, 0984, 2210, or stepping up to the massive 9618 AS and A-level module, the strategy remains exactly the same. Today, we are focusing heavily on security management in operating systems, an absolute heavyweight of a topic that appears in every single examination series without fail. Let me set the scene and introduce you to two very typical students we see every year. First, there's Alex. Alex overloads their answers with raw computer science facts. They'll write a whole page on the history of symmetric encryption, but provide absolutely zero analysis of the question asked. Then we have Sam. Sam rushes. Sam completely misses the command word requirements, writes "use a firewall," and expects full marks on an 8-mark question. Both of them walk out of the exam hall feeling confident, and both of them get their results back, covered in red pen marks. Knowing the facts and scoring the marks are two entirely different skill sets. Today, we are opening up the examiner's playbook to show you exactly how to bridge that gap and build a perfect response. So, let's look at the big question. Why do students who know the textbook inside and out suddenly freeze up or lose crucial marks when faced with multi-step calculations and complex security scenarios? This topic appears in every single examination series, yet it is exactly where candidates consistently drop the ball. We see answers like Alex's, a massive wall of text that gets maybe 2 marks out of 10 because it completely ignores the context. And we see answers like Sam's, a brief, rushed bullet point that completely ignores the command word. The fundamental problem lies in how these specific questions are assessed by Cambridge. It is rarely, if ever, about just finding the right final answer or stating a basic fact. It is about demonstrating exactly how you got there. If you don't show the examiner the internal logic of your operating system scenario, you are effectively leaving your script half-written. The examiner cannot give you marks for what they assume you know. They can only reward what you explicitly prove on the page. To fix this, we are going to tear down the process and rebuild it. Today, we're taking a look behind the curtain to walk through 4 critical acts. First, the core theoretical principles. Second, the step-by-step procedural framework to structure your answers. Third, exactly how to secure those elusive critical analysis points in high-level questions. And finally, the top examiner warnings to avoid, straight from the principal examiner reports. We are going to transform those red pen marks into green check marks.
Let's move to our first section and see how building a solid theoretical foundation is your absolute first step to success. We need to understand the architecture of what Cambridge is actually testing. It's time to break down those computer science-specific assessment objectives. You see, top-performing students don't just write, they structure. They use what we call the PEAL framework. That stands for point, evidence, explanation, and link. You make your point about a security measure. You provide evidence from the specific scenario given. You give an explanation of how the operating system handles it, and you link it back directly to the command word in the question. This is how you cut the filler and keep the action moving in your exam script. If you aren't using the PEAL framework to satisfy those assessment objectives, you are just throwing facts at a wall and hoping something sticks.
Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Now, the crucial point here is understanding the method mark strategy. Examiners prioritize analytical depth over superficial breadth and will heavily reward your logical, structured reasoning. When you are asked to analyze a security protocol, like an access control list, or calculate file permissions in a directory structure, the academic benchmarks require you to show your work step by step. The assessment framework targets distinct cognitive domains: your base knowledge, your understanding, your practical application, and your critical analysis. If you just jump to the final conclusion, like simply stating the system should use biometric authentication, without showing your causal relationships and logical progression of why passwords aren't enough for this specific system, you are leaving the vast majority of the method marks on the table. Show the process, secure the marks. It really is that simple.
And this quote right here brilliantly illustrates what top-performing students do differently. As the principal examiner reports repeatedly highlight, they demonstrate connected, conceptual understanding that transfers seamlessly to unfamiliar contexts. Think about it. Security management in an operating system doesn't exist in a vacuum. It rests on precise definitions and deep integration with other syllabus areas. When you can take a security concept, like defending against a buffer overflow attack, and explicitly link it to memory management concepts or network data structures, you signal to the examiner that you have a master-level grasp of the subject. You aren't just reciting a textbook, you are thinking like a computer scientist. You are moving away from rote memorization and towards evidence-based, analytical reasoning. That is exactly what pushes a student from a B grade into an A-star category.
Now, enough theory. Let's look at how to actually put this into action during the exam with a structured procedural framework. This is the transformation stage. We are going to take Alex and Sam's scattered approaches and turn them into a streamlined, high-scoring system. This is your computer science success blueprint.
When tackling complex past paper questions, you absolutely must follow this exact 5-step standardized sequence to ensure your systematic processing captures every possible method mark. First, you deconstruct the question. You circle the command words. Are you being asked to describe, explain, or evaluate? Those demand completely different responses. Second, extract only the relevant data from the scenario. If it's a 9618 question about a bank's server, ignore the fluff and extract the network topology and current security protocols. Third, select the right analytical framework to apply. This is where your peel structure comes in. Fourth, execute your analysis with absolute clarity in your working, mapping out your logic step by step. And finally, step 5, present your verified results using the precise, correct computer science terminology. No vague words like packer or virus when you really mean unauthorized access or polymorphic malware. This 5-step sequence is your ultimate safety net in a high-pressure exam situation. We've seen Alex rewrite their messy answer using this exact sequence, and suddenly they are hitting every single point on the examiner's rubric.
Now, if the exam question shifts toward practical programming, pseudocode, and algorithmic thinking, you need to seamlessly transition to this specific 4-step practical framework. You have to demonstrate your ability to design algorithms by starting with step-by-step decomposition. Break the big security problem into smaller, manageable subroutines. With the problem broken down, move to appropriate data structure selection. Are you using a 1D array, a linked list, or a record structure to store these user passwords? Follow that up with efficient code implementation, ensuring your logic flows, and finally, conclude with rigorous testing and performance evaluation, utilizing trace tables and test data. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Let's dive into our next section, Act 4, which focuses on satisfying those incredibly difficult higher-order assessment objectives. This is where we run our interactive workshop. I want you highly focused here, because mastering critical analysis is what separates the absolute best candidates from the rest of the pack.
Let's kick off Challenge 1. If I put a complex computer science data table on the screen right now, detailing 2 different operating system security models, you'd have 60 seconds to extract the core trend. Time starts ticking. What are you looking for? You are looking for comparative analysis. Look closely at this slide. It breaks down exactly how you execute it. You cannot just list facts side by side like Alex does. You have to evaluate alternatives and justify your recommendations using this exact structure. If a question asks you to compare symmetric and asymmetric encryption, you must explicitly state both the similarities and the differences. You need to use structured transition words, comparative connectives like whereas, conversely, or similarly. Furthermore, every single comparison must be supported by an evidence base drawn directly from the scenario. And finally, the conclusion. Higher-order objectives demand that you draw justified judgments on the relative importance of your findings. So, Challenge 2. Find the flaw in your own previous answers. Were you actually comparing or just describing 2 things independently? The examiner commentary is always brutal on this point. If you don't use connectives, you don't get the critical analysis marks.
Even with the perfect framework, you have to navigate the absolute minefield of common mistakes. This brings us to the top examiner warnings. These are the pitfalls that consistently catch students off guard, even the ones who studied for hundreds of hours. For Challenge 3, imagine you have a 30-second timer on the screen right now to write 1 perfect peel paragraph. As you write, you have to actively avoid these exact traps. Extracted directly from the Cambridge Principal Examiner reports, these are the top 3 traps that candidates fall into time and time again. Let's break them down. First,
using the wrong formula or algorithm for the context. It literally does not matter how perfect your logic or math is if you are solving the wrong problem. Always double-check your command words. Second, forgetting to check boundary conditions and edge cases. When you are writing an algorithm for an access control system, did you test what happens when the user array is completely empty or completely full? Overlooking extreme data is a massive red flag for examiners. And third, providing answers that are entirely disconnected from the context given in the question. This is the ultimate sin in a computer science exam, and it's exactly what we need to look at next.
Look at this comparison. The absolute most classic mistake is on the left, the generic textbook definition. You must always link every single point to the specific scenario provided in the question. Examiners call this an examiner alert for a reason. If the question gives you a scenario about a busy hospital's operating system security, your answer cannot just be a copy-paste of a generic local area network definition. It must specifically address the context. You need to be writing about patient data, confidentiality, medical staff access rights, or the hospital's internal network boundaries. Context is literally everything. If you give a perfect definition of a firewall, but don't explain how the hospital uses it to protect patient records, you will score 0 marks for application. Let that sink in. 0 marks for knowing the fact, because you didn't apply the context. Let's move to Act 5, the final system. Here is a massive pro tip to help ensure you don't forget these cross-topic connections and boundary conditions in the heat of the exam. Try using a visual story method to encode your security management concepts. Instead of just memorizing bulleted lists, picture a physical security guard enforcing access rights at a door, or a heavy steel vault representing data encryption in the operating system's kernel. By visualizing the logical flow of a security protocol, you make the abstract concepts incredibly concrete. This makes it significantly easier to recall the exact steps and edge cases when you are under the intense pressure of the ticking clock. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. You have to combine this visual memory hack with the 3 golden rules: command word decoding, strict PEL framework application, and a rigid time management matrix during the exam. Armed with this examiners playbook, how will you systematically process the next complex scenario you face? Remember, success in the Cambridge Computer Science exams isn't just about writing down everything you know. It's about structured reasoning, showing your method, and strictly analyzing the specific context you are given. The next time you sit down to a past paper, ask yourself, are you just writing down what you know like Alex, or are you delivering the analytical masterclass the examiner is waiting for? Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to add acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.